We are going to continue our notes on z-scores and probability and look at how z-scores are related to the area under the curve. Remember that in a normal curve, the total area is 1, with the mean, or mu, splitting it up 50% to the left, 50% to the right. And we can look at these standard deviations, or sigma, going up 1, 2, 3. And we can look at z-scores in between those. So we don't need an exact standard deviation distance to look at the probability. And we're going to do that using this function norm.dist. So looking at what is the probability of a z-score less than 2.5? Well, that's on a standard normal distribution where the mean is 0 and the standard deviation is 1. So probability that x is less than 2.5, mean equals 0, standard deviation equals 1. Okay, so this will be equals norm dot dist. There it is. Press tab to select that one. And we need to put the, if we look at our notes, we need that z-score right there, or that a value first, and then the mean, comma in between, then comma standard deviation, then comma the word true. It's always going to be true. So 2.5, comma, the mean is 0, comma, standard deviation is 1, comma, true. And we can press enter. It'll add in the little end parentheses. So the probability that a z-score is less than 2.5 is 99.37, or 0.9937. Okay, well, what about the probability of a z-score greater than negative 0.4? Remember, that's to the right. That's a right-tailed, because it's greater than. So if we're looking at our curve, that if we drew a line, there, okay, that would be everything to the right of that. So that would be everything over here. Okay. Well, our probability is always left tail, so we have to, if we're talking about the area to the right, well, we know the total area is 1, so all we have to do is look at where this z-score is, do the left-tailed calculation, and then subtract that from 1 to get this area to the right. So the probability that x is greater than, what do we say, negative 0.4, negative 0.4. Okay, well, the mean equals 0, standard deviation equals 1. So we want equals norm dot dist, and we want negative 0.4, comma 0, comma 1, comma true. Now, you'll notice I forgot to add in that 1 minus. This would give me the probability that it's less than negative 0.4, so we want greater than, so we got to do 1 minus. There we go. So equals 65.54%. Okay. And then probability that's between, well, if we want to do something that's between, so we've got two values here, then all we have to do is, here's the left of this, here's to the left of the A value, here's the B value, okay, and all we have to do is find the left tail of the A value, and then subtract off what's the left tail of the b value, and then we're left with what's between them. So the probability that z-score is between -1 and 1. Well, you could probably tell me that just from the empirical rule, but it's nice to confirm that. So we want the probability that it's between -1 and 1. So the mean, of course, equals 0. Standard deviation equals 1. So the formula is equals norm dot dist. And we need to do the right bound first. So we want 1, comma, 0, comma, 1, comma, true. Okay, that gives us the right bound right here with 1 minus norm dot dist of the left bound, which is -1, comma, 0, comma, 1, comma, true. Okay, there it is. Just like the empirical rule, a little bit more than 68%, but good enough. 68.26%. Okay, so that's how you find, if you're given a z-score, how you find the probability related to that z-score, that something is less than, or something is greater than, or something is between two values. But what if we want to go the other way? Say we know the probability and we want to find, well, where is that z-score? Or what is the z-score related to that probability? And we're always thinking probability to the left. So if we get something that's to the right or between, we have to translate it into probabilities that are to the left. So first one, what is the z-score for a probability of 0.75? And our formula is equals norm dot inverse, INV, and then the probability and the mean and the standard deviation. So the probability that this z-score is less than A is equal to 0.75, and we want to figure out what that x value is. So we know the mean is 0, the standard deviation is 1 because we're talking about a z-score. So we're going to use equals norm dot INV, and we want to put in the probability, so 0.75. Always got to turn it into a decimal. And then the mean, which is 0, and the standard deviation, which is 1. And we don't need the word true here because we're using inverse function. Okay, so it's 67.44%. Or, sorry, the z-score is 0.6744. So 0.67. All right, next one. Find the z-score so that 10% of the area is above it. So that's talking about 10% is right-tailed. So if we are looking at our marker, we're looking for a z-score somewhere here, and we're told that, well, the 10% is above it. Okay, so 10% is above it. So we got to translate our probability into left-tailed. That means we want, so that we get everything over here. So all we got to do is 1 minus 10%. That would give us this, which is, of course, 0.9. Okay. So the probability that x is less than a, because we always want it to equals 0.9. The mean equals 0. Standard deviation equals 1. So equals norm dot inverse 0.9, mean is 0, standard deviation is 1, and enter. Okay, so that z-score would be 1.28, right there, 1.28. All right, now a little bit trickier. Find the z-scores for the middle 40%. Okay, so the middle 40%, so that's going to be, well, that's 34%, so somewhere right around here. Yeah, anyways, it's centered. So, okay, so the middle 40%. Well, if point 40 is in the middle, right there, okay, that means that the area outside of it is 1 minus 0.40, which is 0.6. Okay, but we need to divide that on the right tail and the left tail. So we've got to divide that 0.6 by 2. So that gives us over here 0.3 here, and over here 0.3. Okay, so now I can finally figure out how much area is to the left and how much. So we know in the middle here is 0.40. We know over here is 0.30. Okay, so to find the area in the middle, we take the left tail here of 0.3 plus 0.4, which is 0.7, and subtract the left tail of here, which is 0.3. And that'll give us a z-score here and a z-score here. So we've got to do two separate calculations. So first we've got to figure out the z-score for the probability that is less than a that is equal to 0.7. Okay, so that's this one right here. The probability to the left of it is 0.7 because you add 0.3 plus 0.4. And that tells you that you can use that to figure out what the z-score is for the right bound. Okay, so mean equals 0, standard deviation equals 1, and we want equals norm dot inv of 0.7, comma 0, 0, comma 1. Okay, so the z-score there is 0.52. Okay, then we want the other bound, the probability that x is less than a equals, and now we want to do this one. Well, the probability to the left of that is 0.3. So equals 0.3. The mean equals 0. Standard deviation equals 1. So we want equals norm dot inv 0.3, comma 0, comma 1. And notice, because it's the middle, they're mirror images of each other. So you could have saved yourself some work and just did, well, since we know that the right bound is positive 0.52 and it's in the middle, the left bound is going to be the same z-score, negative 0.52. Okay. And if you did it right, you would get the same answers here and here. Just a negative difference. Okay. So negative 0.52 and 52. All right, that should be it.